Hello, notes 4.2 are on radian measure and angles on the Cartesian plane. And before we move on, I just want to warn you that this video is going to be probably a lengthy video because there's a lot of information that we're going to be going over in this video, but it's also going to be such a crucial piece for the foundation of this unit as well as next unit. So be 100% sure you're totally engaged with everything that we're doing in this video, okay? So the first thing I want to do is review special triangles, which is nothing new for this year. That you guys already have learned about special triangles. So there are two different types of special triangles. We have a 45, 45, 90 triangle. So we have a right triangle here. This is 45 degrees. This is 45 degrees. So remember, that means that these lengths are congruent. So we've got a ratio of 1 to 1 to the square root of 2. Now, these special triangles are really important for you to know. It's the foundation for the rest of this unit, okay? And then we also have a 30, 60, 90 triangle. So we'll call this a 45, 45, 90 triangle, okay? But we also have a 30, 60, 90 triangle. So in our 30, 60, 90 triangle right here, we're going to say that this is 30, that this is 60, so and here we have a right angle, that's our 90-degree angle, and the ratio is that this is 1 to 2, and this is the square root of 3. Okay, now we're going to write our special angles or our special triangles in radians, but before we do that, I have to figure out what all of these degree measures are in radians. So let's just write down that this is a 30, 60, 90 triangle. Okay, so in radians right here, I'm going to take 45 degrees and I'm going to convert it to radians by multiplying it by, pi over 180. Okay, and I know that 180 and 45 are both divisible by 45. 180 divided by 45 is 4. 45 divided by 45 is 1. So I get pi over 4. So in this special triangle right here, the ratios are the same. I still have a 1 to 1 to root 2. But instead of having a 45-degree angle, we're just going to say that this is pi over 4 and that this is also pi over 4. Okay, now let's do the same thing with our 30-degree angle. So our 30-degree angle, I'm going to multiply it by pi over 180, and I'm going to see how many times, does 30 go into 180? It goes in 6 times, so I can cancel this out to make this a 6. I can make this a 1, so this right here is just pi over 6. So that's what 30 degrees is. So right here we know that this 30-degree angle is like saying pi over 6 in radians. I'll do the same thing for my 60-degree angle. 60 times pi over 180 is going to be, let's simplify right here. They're both divisible by 60. This becomes a 3, this becomes a 1, so I get pi over 3. So I know that this angle up here is pi over 3. But one thing I want you guys to realize is if this is 30 and this is 60, this is twice as large. So if I have pi over 6, when I double it, I should get pi over 3 as my answer up here. Okay, so my triangle right here is going to be same ratio of sides. So let me draw this a little bit better. So it's the same ratio of sides, except this is going to be 1 root 3, 2. There's nothing different about that. I still have my 90-degree angle there, but now instead I'm going to say that my 30-degree angle is pi over 6, and that my 60-degree angle is pi over 3. Okay, so that's the basis right now for what we're going to do for the rest of this lesson. All right, so now we want to find the 6 trigonometric ratios for each of the special triangles. These are values that we're definitely going to need to have like down cold, okay? So before we do this, let's just remind ourselves what these different values, what these different ratios represent. So remember, we're going to use SOHCAHTOA right here. And when we have SOHCAHTOA, we know that sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent, okay? So I'm just going to have this moved over a little bit, and then we're going to go ahead and draw our triangle out so that way we can figure out our trigonometric ratios, okay? Okay, Also, we need to make sure what the cosecant, the secant, and the cotangent are. So our inverses are going to be, so I'm just going to write here, our inverses are going to be cosecant for sine, secant for cosine, and cotangent for a tangent. So all of that stuff right here is really important to know because we have to be able to figure out these values. Now when we say the inverse, that means that the cosecant would just be the hypotenuse over the opposite. Or I could just do the inverse, I could flip, do the reciprocal of whatever sine is. Okay, so let's go ahead and start by drawing in our triangle. And we're going to use the same triangle that we used right here. So the first example that we have here is I want to figure out what will happen if we have a 45-degree triangle, okay, or a 45-degree angle. So that means that this right here would be pi over 4. We have a right angle right here. This is 1, this is 1, this is root 2. And this is the angle that I'm looking at. So by looking at this angle right here, I can identify that this is my opposite, this is the adjacent, and this is the hypotenuse. So to figure out these values, I have to do, for sine, I have to do opposite over hypotenuse. I'm going to do some work on the side here. So when I do the opposite, it'll be 1. The hypotenuse is the square root of 2. So I get 1 over root 2, but I'm not allowed to have a radical in the denominator, so I have to rationalize it by taking the square, or multiplying by the square root of 2 over 2. By multiplying by the square root of 2 over 2, I haven't changed anything. I'm just multiplying by 1. But by multiplying by the square root of 2 in the denominator, the square roots cancel each other out, so I get root 2 over 2. So therefore the the sine of pi over 4 is root 2 over 2. Okay? Now that I figured that out, I need to find the cosine. Well, to find the cosine, I would have to do the adjacent, which is still 1, over the hypotenuse, which is still root 2. Rationalize my denominator, I get root 2 over 2 again. So that means that my cosine and my sine for a 45-degree angle, or a pi over 4, because remember pi over 4 is 45 degrees, is going to be root 2 over 2, which is not review for you, or sorry, which is not new for you. This is review. The only difference is we're looking at this as pi over 4 in radians instead of 45 degrees. So we're looking at it in terms of radians, but it's the same exact idea, okay? Now, to find the tangent, I have to take the opposite and divide it by the adjacent. Well, my opposite is 1. My adjacent is 1, so 1 divided by 1 is 1, just like the tan of a 45-degree angle is still 1, okay? Now, the next thing I need to do is find the cosecant. Well, to find the cosecant, instead of doing opposite over hypotenuse, I'm going to do hypotenuse over opposite. So I'm going to do the square root of 2 over 1, so I get root 2 over 1, which is root 2. So that's what I get for the cosecant of pi over 4. Okay, to find the cotangent, or sorry, the secant, I'm going to do hypotenuse over adjacent. I'm going to do the inverse. Well, the hypotenuse is radical 2, or root 2. The adjacent is 1, so it's root 2 over 1 again, so I get root 2. Okay, and then lastly, I need to do the cotangent, which is adjacent over opposite, because I'm just doing the inverse of what tangent is. So again, I get the adjacent is 1 over 1, so it looks like this piece right here, so I just end up getting 1. Okay, these are all very important values that you need to make sure that you have memorized. All right, we're going to take a look at what happens if we have a pi over 6 angle in our triangle. So if I have a triangle that has an angle that is pi over 6, so I'm going to draw this on the side over here. Okay, so if this is pi over 6, remember pi over 6 is just 30 degrees, okay? So right here, if this is pi over 6, then this has to be 60 degrees, oh, sorry, or just pi over 3, okay? Here's my right angle, but again, we don't really care that this is 60 degrees right here because I just want to go from this angle right here. And if we have our special triangle, when we look at it, we know that it's going to be in the format 1, root 3, 2. So we know this is going to be a 1, a root 3, and a 2. And remember, it can be a multiple of these values, but when I do my ratios, it'll simplify out, cancel out, and give me the same answer as we get with our most basic one right here. Okay, so now if this is my angle right here, we know that this is the opposite, this is the adjacent, and this is the hypotenuse, okay? So to find the sine of our angle right here, I'm going to, let me just separate this here. To find the sine, I'm going to do the opposite over the hypotenuse, okay? Or I'm just going to do 1 over 2. So I get 1 over 2. It's already simplified. That's as far as I can go, okay? So that is the sine of my 30-degree angle, which we now are calling it a pi over 6 angle, okay? So that's the answer for our sine. Now let's do our cosine. Remember, cosine is adjacent over hypotenuse. So the adjacent is the square root of 3. The hypotenuse is 2. So I'm going to say that this is root 3 over 2. Okay? So once I've done that, I'm all set with my cosine. Next, I need to figure out what my tangent is going to be. So here's where things get a little bit trickier, so you want to be really careful. The tangent is going to be the opposite over the adjacent. So when I do that, I get 1 over root 3. However, I can't have root 3 in my denominator, so I'm going to multiply by root 3 over root 3. So I get root 3 over, these roots cancel each other out, so I just get 3. So the tangent of pi over 6 is just root 3 over 3. Okay, so that's what I get for my tangent value right here. Okay? All right, so next I need to figure out the cosecant. Well, remember, cosecant is the inverse of sine, so instead of opposite over hypotenuse, I'm going to do hypotenuse over opposite. So hypotenuse is 2, opposite is 1, so I'm going to take 2 divided by 1, so I just get 2. So 2 is what cosecant is going to be of pi over 6. Okay? Next I need to do my secant. Well, secant is the inverse of cosine, and if cosine is adjacent over hypotenuse, then secant is hypotenuse over adjacent. So I'm going to do 2 over root 3. Not allowed to have a root in the denominator, so I'm going to multiply by root 3 over 3. My numerator becomes 2 root 3. Root 3 times root 3 is just 3. So I get 2 root 3 over 3. So that's my answer here, 2 root 3 over 3. So that's the that's the secant of pi over 6. All right, and then we will do just the cotangent really quickly, and then we'll be done with this question right here. So the cotangent of pi over 6 is going to be the opposite of the tangent. So if tangent is opposite over adjacent, then cotangent would be adjacent over opposite. So I would take root 3 over 1, which is just simply the square root of 3. Okay, and I'm all set for my 30-degree angle or my pi over 6 angle. Okay. All right, so let's go ahead and do this one last time with our pi over 3 angle, which is the same thing that we will have above. It'll be the same triangle, but I'm just going to place the pi over 3 in the same spot right here. So when I do this right here, I'm going to say pi over 3 is going to go in this corner over here for this angle. Therefore, this is going to be root 3. The height right here is root 3. The base is 1, and the hypotenuse here is still going to be 2. Okay, so we're going to do everything exactly the same way that we did before. So the first thing I need to do is find the sine of my angle. Well, to find sine of pi over 3, I need to take the opposite, which is root 3, and divide it by the hypotenuse, which is 2. So I'm just going to say that my answer is going to be root 3 over 2. Okay, so I'm all set for that piece. Let me just try to make this smaller so we can fit it all in. Okay, so then the next thing I'm going to do is find the cosine. Well, the cosine is the adjacent over the hypotenuse. So the adjacent is 1, the hypotenuse is 2, therefore my cosine is just 1/2. Okay? Next, to do the tangent right here, I'm going to take the opposite and divide it by the adjacent. So I get root 3 over 1, which is simply root 3. So right here, my answer that I get is just root 3. Okay? Now, to find the cosecant, I'm going to do the the hypotenuse over the opposite. So remember, cosecant is always the opposite of, or the inverse of sine. If sine is opposite over hypotenuse, we're going to do hypotenuse over opposite. So we'll get 2 over root 3. Rationalize that denominator, just like we did up here, and we end up getting 2 root 3 over 3. So this value right here, the cosecant, is 2 root 3 over 3. Now, if you notice, these values that we're getting here are swapping with between pi over 6 and pi over 3. So if sine of pi over 6 is 1/2, notice the cosine of pi over 3 is also 1/2, which is something that you should have been looking at last year as well in the 3U class. So now if I want to figure out the secant of pi over 3, I'm going to do the inverse of cosine. So if cosine is adjacent over hypotenuse, I'm going to do hypotenuse over adjacent. So I get 2 over 1, which is just 2. Again, notice how these two swapped with each other right here. Okay? And then lastly, I want to figure out the cotangent of pi over 3. So if tangent is opposite over adjacent, cotangent is adjacent over opposite. So when I rationalize my denominator, I get root 3 over 3. So this answer right here is going to be root 3 over 3. And that is what I will end up getting for my cotangent. Okay, notice how my tangent and my cotangent swapped with each other between pi over 6 and pi over 3, because it's essentially the same triangle. We're just looking at a different angle in our triangle. Okay. All right, so now we're going to talk about the unit circle. And again, this stuff that I'm going to tell you guys right here is going to be a lot of information, but it's really, really, really important. So the first thing that I want to do is I want to color code this so you can kind of see what's happening right here. So along my x-axis, I've got these degrees right here, okay? And then I have my y-axis right here, okay? And then I have multiples of 30 degrees going on. So I want to color code my multiples of 30 degrees. So here's a 30 degree, a 60 degree, and a 90 degree right here. Okay, we've got another 30 here, another 30, and another 30 to make our 180 degrees. We're going to keep going right here. This is another 30, another 30, another 30 right here, and another 30 right here. Okay, so let's go ahead and fill in all this information first of all. So this is 0 degrees. Okay, if we're going up by 30s here, this is 30 degrees, 60 degrees, 90 degrees. We've got 120 degrees here, 150 degrees here, and 180 here. This is 210, 240, and 270. Okay, and again, this is nothing new for our degrees right here. Sorry, this shouldn't be 310, this should be 300, and this is 330. So you guys already know this stuff from 3U. Now the question is, what are its corresponding radian measures? Well, 0 degrees is still going to be 0 radians, okay? And we figured out over here that if we have pi over 6, that's 30 degrees. So 30 degrees and pi over 6 go together. So therefore I can say that this is pi over 6 radians. Well, if this is 1 pi over 6 radians, then this is technically 2 pi over 6 radians, but we call it pi over 3 to simplify our radians. So this is pi over 3 radians. Okay, so 1 pi over 6, 2 pi over 6, this is technically 3 pi over 6, but we're going to simplify this and say it's pi over 2. And that should make sense to you that it's pi over 2, because don't forget that 180 degrees is pi radians. So if I can say that this is pi radians and this is 180 degrees, then 90 degrees would be pi over 2 radians. Okay, so remember, 1 pi over 6, 2 pi over 6, 3 pi over 6. Now we're at 4 pi over 6, but we're going to reduce this to 2 pi over 3 right here. So we can say this is 2 pi over 3 radians. Okay, this would be 5 pi over 6, and it doesn't simplify, so we'll just say it's 5 pi over 6. This is 6 pi over 6, but we just simplify it to just pi. Therefore, this would be 7 pi over 6. Okay, this right here would then be 8 pi over 6. Sorry about that. So we'll say that this right here is 8 pi over 6. However, we'll simplify it to say that it is 4 pi over 3. So that's what this is in radians, 4 pi over 3. We're at 8 pi over 6, so this would be 9 pi over 6. But we'll say that this simplifies to 3 pi over 2 because they're both divisible by 3. So this is 3 pi over 2, which should make sense to you because it's 1.5 around right here. So this is half, this is a whole, this is another half, this is going to be another whole, okay? So we left off at 9 pi over 6, which means that this would be 10 pi over 6, but that simplifies to 5 pi over 3. So we'll say this is 5 pi over 3. So 10 pi over 6, this would be 11 pi over 6. There's nothing in common with 11 pi and 6, so we'll say it's 11 pi over 6, and now we're back at 0, or we could also say that this is 2 pi. Now we could keep going, right? So if this is 12 pi over 6, this would be 13 pi over 6, 14 pi over 6, 15 pi over 6, so on and so forth. Okay, so we've dealt with all of our 30-degree angles, but we also have special triangles that have 45-degree angles. So we're going to do the same thing, except this time we're going to look at our 45-degree angles. Well, this is still 0, right? This is 45 degrees. Add another 45 degrees on, we get 90 degrees, okay? Add another 45 degrees on, we end up getting 135 degrees. Okay, so let's write this a little bit more clearly, 135 degrees. Add another 45 degrees on, right here we get to 180. Add another 45 degrees on, right here, we get to 225 degrees. Another 45 degrees on brings me to 270. Another 45 degrees on will bring me to 315 degrees. And then another 45 degrees will bring me to 360 degrees, which remember we said is the same thing as 0 degrees. Okay? All right, so now 45 degrees, we figured out already, 45 degrees is going to be pi over 4. Now on the unit circle, that should make sense because we've got 1, 2, 3, 4 sections to get to pi. So this has to be pi over 4. Okay? So then this right here has to be 2 pi over 4, but 2 pi over 4 is just pi over 2. Then this has to be 3 pi over 4. Okay, and then this is 4 pi over 4, just pi. This right here is going to be 5 pi over 4. This is 6 pi over 4, which is 3 pi over 2. This is 7 pi over 4. And then this brings me back to 8 pi over 4, which is 2 pi. Okay, hopefully we understand where all of these values are coming from because this is crucial. Okay, so now we need to talk a little bit more about what the unit circle really entails. So when we talk about the unit circle right here, there's something really important that we need to know. And that is as follows. And again, this is this piece right here is going to be review for you. But if I were to draw out my unit circle, I know right here that my radius is going to be 1, right? So if my radius is 1, so I'll just draw a random triangle right here. If my radius is 1 and my theta is right here, then this coordinate right here is always going to be x followed by y. So this point on my circle is xy. And in the triangle right here, this is x because I'm going to the right by x to get to this point, and this is y. So to find the sine of theta, I would take the opposite, which is y, and divide it by the hypotenuse, which is my radius right here, which is 1. So therefore I can conclude that sine of theta equals y. I need you to write this down because this is really important. The sine of theta is equal to y. Okay? We also know that to find cosine of theta, this is the stuff right here that I need you to write down. To find cosine of theta, I'm going to do adjacent over hypotenuse, so it'll be x over 1, which is going to just be x. So I can say that cosine of theta is equal to x. Okay? Now to find the tangent of theta, I have to do opposite, which is y, over adjacent, which is x. So I will get y over x. Okay? To find the secant, let's do cosecant first. I'm going to do the opposite of sine. So instead of y right here, I'm going to say it's 1 over y. Secant is going to be the opposite of cosine. So I'm going to do the inverse of x, so it's going to be 1 over x. And then cotangent is going to be the opposite of y over x, so I'm just going to say x over y. Okay, and this right here is going to be really important for us to be able to move on to the next piece. Okay, so in our first triangle that we see here, we have a 30-degree triangle. So that means that this angle right here is 30 degrees. So I want to figure out what my coordinate is going to be. Well, my x value is going to be my cosine. Okay, so I'm going to go back to pi over 6 and I'm going to figure out, well, what was my cosine? It was root 3 over 2. So therefore, I can say right here that my x value right here is going to be the square root of 3 over 2. Okay, and then remember the sine is going to be your y value. So if I look right here at my y value, the sine of pi over 6 is 1/2. So I can say right here that this is 1/2. Okay, so now that I figured that out in this triangle, I'm going to look in my unit circle and find all my other triangles that look the same. Well, I have this triangle is also 30 degrees right here. We have this triangle right here, which also is 30 degrees, and we have this triangle right here, which is also 30 degrees. Okay, so now that I've done that, that means that I can figure out these sets of coordinates right here. So in order for me to be able to do that, I'm going to identify really quickly what these coordinates are, just like what we did before. So we know that the y value is sine and the x value is cosine. Okay, so to figure out these values right here, we know that this is going to be root 3 over 2. That's my x value. It's going to be root 3 over 2. However, it's on the negative side because this is the origin 0, 0, right? So that means that this coordinate right here would be negative root 3 over 2. The y value, though, is still positive 1/2 because it's still above the x-axis, okay? Over here, for this one right here, I've got root 3 over 2 and 1/2, but they're both negatives because my x and my y values are negative in this quadrant, okay? And then lastly, over here, we have root 3 over 2 and we have 1/2, but my root 3 over 2 is positive because it's in the fourth quadrant. For my x value, it's going to be positive. My y value is going to be negative 1/2, okay? So now that I've done that, I want to go ahead and start looking at my 60-degree angle. So in my 60-degree angle, my triangle that's formed by my 60-degree angle, it's going to look like this right here. And this angle right here we can say is 60 degrees, okay? So in order to be able to do this one right here, I'm going to look at my pi over 3 information. So if I want to figure out sine and cosine of pi over 3, we figured out right here that the sine is root 3 over 2 and the cosine is 1/2. Remember, sine is y, cosine is x. So I can say that my coordinate right here, up here, is going to be 1/2 and then root 3 over 2. Okay, the next one that's like that is this 120-degree angle right here, but this is going to be negative 1/2 positive root 3 over 2. Okay, my next one is this 60-degree angle right here, or 4 pi over 3. This time right here, this is going to be negative 1/2 negative root 3 over 2. Okay, and then over here, my last one that I have that's like this is going to be positive 1/2 because my x value is positive and my y value is negative. So it's 1/2 negative root 3 over 2. Okay, The last triangle that I'm going to look at is my 45-degree angle triangle, or my pi over 4 triangle. Well, pi over 4, if I look at what we got for sine and cosine, they're the same. It's root 2 over 2 and root 2 over 2. So my x and my y are both root 2 over 2. So I'm going to say this is root 2 over 2, root 2 over 2. Here's my next 45-degree angle, and it's going to be negative root 2 over 2, positive root 2 over 2, because x is negative, y is positive, okay? For this next one over here, both x and y are negative, so it's negative root 2 over 2, negative root 2 over 2. And in this last example here, x is positive, so root 2 over 2, but y is negative. So it's root 2 over 2, negative root 2 over 2. All right, last piece is nice and easy. I know that my radius is 1. So right here, my x value is 1, my y value is 0. Up here, my x value is 0, my y value is 1. Over here, it's to the left 1 and up none, so it's negative 1, 0. And then at 3 pi over 2, or 270 degrees, it will be 0, negative 1, okay? It's really important that you know the unit circle and that you have all of the information in your unit circle memorized. Let's apply this information. The first question here says to determine the exact value of each trigonometric ratio. So I want to find the sine of pi over 2. So I'm going to go to my unit circle, and I'm going to look at pi over 2. I know pi over 2 is right here, and I know sine is y, so the sine of pi over 2 is equal to 1. Okay? The next one that I need to do is the cotangent of 3 pi over 2. Okay? So remember, we figured out that cotangent is x divided by y. So right here, I'm going to take my x value, which is 0, and I'm going to divide it by y, which is negative 1, so I end up getting 0. Okay? The next piece says to find the cosine of 5 pi over 4. So I'm going to go to 5 pi over 4 right here on my unit circle, and cosine I know is x, so I'm going to write down my x value. So my answer is negative root 2 over 2. Okay? And then my last question here says to find the cosecant of 11 pi over 6. Well, I know cosecant is 1 over y, so I'm going to take my y value and I'm going to divide it. I'm going to do 1 over whatever my y value is here. So to figure this out, I would say 1 over negative 1/2 right here. Okay, so then this means 1 divided by negative 1/2, or 1 times negative 2. So my answer is going to be negative 2. Okay? All right, guys, one last question. Thank you for sticking with this video. I know it's been a long one. It says if tangent of theta is equal to negative 7 over 24 between 0 and 2 pi, which means 0 and 360, evaluate theta to the nearest hundredth. So if you guys remember the cast rule, right here, we know that tangent is positive here and here, which means that tangent is negative in the second quadrant as well as the fourth quadrant. Okay, so since we have a negative tangent, we know that our answer is going to be either in the second quadrant or the fourth quadrant. Okay, so what I'm going to do is I'm going to draw a picture of this. So I know that it's 7 over 24. So here, if I draw a picture of it, here's my diagram, and I know that my theta is going to go right here. And I know that tangent is opposite over hypotenuse, so I know this is 7 over, tangent is opposite over adjacent, so this is going to be 7 over 24. Okay, so how do I figure this out? Well, I need to actually find the inverse tangent of 7 over 24. So I'm going to go into my calculator and I'm going to type in inverse tangent of 7 over 24. So the inverse tangent of 7 divided by 24 is going to be, sorry about that, I gotta control enter this, is going to be 0.28 because it asks us to round to the nearest hundredth. Now be really careful. Your calculator needs to be in radian mode in order for this to work for you. If not, it'll give you an answer in degrees. So you need to change your mode into radian to get the right answer. So that means that theta could be 27 or 0.28. Okay, so we figured out that theta could be 0.28. Well, we know that this is 0. We know that this is at pi over 2. We know this is at pi, and we know this is at 3 pi over 2. Okay, so based on that information, we need our angle to be in quadrant number 2, and we also need our angle to be in quadrant number 4. Well, pi over 2 radians is approximately, let's calculate this, pi over 2 radians is approximately 1.5. So that means that right here, this is approximately 1.57 up here. Therefore, our answer cannot be 0.28 because that's in the first quadrant. So the question is, what is this theta right here? Well, I want to figure out how far I'm going right here. Well, if I go the full way, it's pi. But it's 0.28 shy of pi. So to figure out my answer, I would say that it's pi minus 0.28, which is approximately pi minus 0.28 is approximately 2.86. So that's one of my answers. So 2.86 is one of my answers for what theta could be. But it can also be in the fourth quadrant. So I know right here, my answer right here is going to look something along these lines right here. So when I do this question, I want to figure out what this theta is as well. If I have 360 degrees, or 2 pi is the full way around, this is 0.28 radians away from a full 2 pi. So I'm going to figure out 2 pi minus 0.28. And I get approximately, let's figure this out, 2 pi minus 0.28. And I get approximately 6.00. So that's my other possibility for what tangent of theta could be. Okay? All right, I know this was a lot to take in. Make sure you are studying your unit circle. This is really important, and make sure if you have any questions, you let me know. All right, I'll see you next class.